All right, we're almost to the end of this video series. We're going to talk for a minute about cloning virtual machines and then talk about network settings. And finally, in the last video, summarize everything in chapter 2. Instead of creating a brand new copy of a brand new VM for every um, every instance of a specific VM you need. Particularly if you've got a VM that is already in the right state, or alternatively, if you have a VM that's in the right state and you want to experiment with two possible choices, um, what you can do is clone it and make each choice a direction, a development track, as it were. Anyway, um, you don't have to start from scratch every single time. You can clone the VM. That will leave the VM in its current state. Then you have another one. This is actually kind of one of the things that allows um, cloud services to spawn new VMs at will, because they probably have a library of clones and templates, and they just spin up a new one. And you feed it some new information, say new usernames or a new host name, give it a new IP address, let it give itself a new virtual MAC address, etc. Now, the first thing you're going to do is choose the type of clone. Your options here are full and linked. If you do a full clone, it's going to take the whole thing, duplicate everything, and bam, you got a new VM. If with a linked clone, the clone of the VM is kind of dependent on the state of the base copy. It's going to refer back to the base copy for some of its configuration. Um, this saves disk space, but if you make major changes to the base image, the clone will also change. You can decide to now if you know you're going to have the VM, the two VMs, the clone and the clone and the parent coexisting, running at the same time in the same hypervisor, you should probably make sure that it reinitializes the clone's MAC address. What it will do is take the OUI, the MAC address, probably keep the OUI because they're even in a virtual machine, there are OUI, organizationally unique identifiers, which indicate, hey, this is a VMware virtual NIC or what, yada yada. Um, Give it a new um, EUI64, or actually no, strike that, not EUI64, that's IPv6, so forget I said that. Give it a new interface ID, essentially. You don't have to do that if the two VMs are not going to coexist. If you're going to take the clone and walk it over to another machine, and it's not going to be on the same subnet, that MAC address collision no longer matters. But if you're the least bit worried, make sure you give it a new MAC address. So whether they're on the same subnet or not, they'll be happy. Then you can decide how the cloned VM snapshots will work. Now, you might want to throw these away. If the clone comes with snapshots, and then you might actually roll back to a state before what you wanted. Um, you can um, you can keep snapshotting going forward, but then you'll have the snapshots of the new VM. Let's talk briefly about network adapters. VirtualBox will give you up to 4 network adapters. This is, I think, also true of VMware. You might have to jump through a few more hoops. You don't have to use them all. You'll probably only need one, and if you don't need the others, just leave them alone. Leave them disabled. It won't make a difference. You can set them up to be not attached, as in literally not on a network, NATed, or on a NAT network. You can make it a bridged adapter. A bridged adapter will basically take the frames that are coming down, the frames that are, okay, it'll take the layer 2 information, the information that's coming down the protocol stack from layer 3 inside the guest OS's protocol stack, and hand that to layer 2 on the host machine. So the host machine layer 2 will encapsulate with an Ethernet frame related to the physical NIC on the host, depending on what interface it's going out of, wireless or wired or whatnot. So that's a bridge. So there's literally a bridge between the protocol stack of the guest device of the guest OS and the lower level of the protocol stack of the host OS. Now, what it might actually do is do some network it might try to do some network address translation in there. You might also actually see in the guest OS that it thinks it has the same IP address as the host machine, depending on how it works. You can also have an internal network. Say, for example, you set up a little sandbox for your virtual machines, and you give them all the same internal network. They'll talk to each other. It's like they're all plugged into the same switch, but they may not be able to get out. There's also the host-only adapter. The host-only adapter can talk to other VMs in host-only mode, or it can talk to the guest OS. Sorry, the host OS. So you can, depending on how you do this, you can literally use a browser window to reach through and access service on the guest OS. Then there's the generic driver, and it kind of looks like this. You've got your adapters 1, 2, 3, and 4. If you want to enable them, you can do that. You can see its MAC address. If you want to change its MAC address, you can click the refresh button. You can tell it whether the cable is connected or not. Literally, whether it should behave like the NIC is receiving a carrier signal from the switch or router that it would otherwise be plugged into. You can change them whether they're NAT, change the adapter type, change whether they're in promiscuous mode or not. If you're going to use a VM for packet sniffing or protocol analysis, you're going to want to put it in promiscuous mode, so it yanks a copy of every frame coming to it on the wire, instead of looking at every frame, filtering on the basis of MAC address, and then tossing everything that's not broadcast or multicast or unicast to it. So in the last video, I'm going to summarize the whole chapter, and we'll be done. Thanks for watching.